What we're learning about today is we're learning about reflections. What do you guys think of when I say the word reflection?
Mirror, your face.
Mirror, your face. Okay, your face in a mirror. Your face looking back at you in a mirror, right? Okay. All right. Let's get, though, a more mathematical definition. Okay, so I want everyone writing this down, the math definition. Okay, a reflection is a flip across a particular line. If you have a highlighter, it's good to have one for today's notes specifically. We're going to be highlighting some things in our problems that we're going to work on. Okay? Okay, so we've determined that a reflection is a flip across a particular line. I want to review a couple words with you right now. The first one that's review that you guys have actually learned before, perpendicular. Do you guys remember what that one means?
Crossing.
Crossing. Okay. It's lines that are crossing that are forming what kind of angle?
90 degrees.
90 degrees. Okay. So perpendicular is a word that describes two lines that create a 90-degree angle. Okay, and then the last review term that we're going to use, and I'm going to purposely leave some blank space over here in this area because we're going to draw a picture over here. So don't make this definition go all the way over. Leave some space over here. Okay. So our last review term is perpendicular bisector. Now we know what perpendicular means. It means two lines forming a 90-degree angle. What does bisector mean? Yeah, it cuts in half, right? So a perpendicular bisector is a figure that cuts a segment in half and is also perpendicular to the segment.
Did that say that cuts?
Yes. Yeah, I forgot the T and then I tried to squeeze it in and it says that cuts. Okay, so a perpendicular bisector is a figure that cuts a segment in half and is also perpendicular to the segment, okay? So we're going to draw a picture here to kind of clarify for you guys why these words here are important in relation to reflections, okay? So it says a reflection is a flip across a particular line. So let's draw a line. Let's call this line L. Give it a name. It's line L. Okay, and now I'm going to say that this line is my line of reflection. So what is a line of reflection? A line of reflection is the line that I'm going to flip the image over. Okay? So I'm going to take a point or an image and flip it over that line L. Okay? All right. So here's my point. I'll put it here, point P. Okay, now if I'm going to flip P over line L, okay, where is it going to end up? If I reflect it over line L, is it going to end up over here? Or way down here? Or way over here? No. It's going to end up the same distance, and it's going to kind of go across, and it forms a 90-degree angle when it goes across, okay? So let's estimate a 90-degree angle here. And when I reflect this point P across, I'm going to have the same distance on the other side to P prime. And P prime, the line it creates with the segment, is also going to form another 90-degree angle. So these two segments are congruent. Okay, this segment here and this segment here are the same distance, and they're both creating a 90-degree angle with line L. The segment that's formed between P and P prime is perpendicular to line L, creates 90 degrees. Okay. Now that's what has to happen in order for this to be a true reflection. Because if P prime wasn't making this 90-degree angle and it was over here, when I fold this, would it end up onto point P? No, it would end up somewhere different, right? So in order to be a true reflection, this segment and the line of reflection end up being perpendicular. This segment is also bisected, cut in half, by the line of reflection. So the line of reflection, line L, is also the perpendicular bisector of the segment. So L is a perpendicular, is it okay if I abbreviate perpendicular? Okay, is a perpendicular bisector of the segment P prime. Okay. Okay, do you guys need more time writing anything before I move this? Yes, you need one more minute? Okay. All right, so let's take a look at a couple of our example problems, okay? It says, draw the image of each triangle after a reflection across line L. So I want you guys to highlight line L. This is our line of reflection, okay? And now what we're going to do is we're going to use our trace paper to help us make this reflection, okay? When we use our trace paper, the trace paper is one method to do a reflection. If you guys want to use this method on a quiz or a test, I will give you trace paper to use, okay? All right. If you don't like this method, there's a second method which I'll show you on the next problem that we do by counting. So you're going to see the trace paper, then you're going to see the counting, okay, and then you'll get to decide which one you like better. All right, so for the trace paper method, what we do is we take our trace paper and we put it on top of the graph and we trace over the whole line of reflection from arrow to arrow. Okay, then what we do is we trace over the whole image. I'm going to put dots on my vertices just so I really know that's where the corners are. And I'm going to label them. This one's A, this one's B, this one's C. Now notice I did not trace over the X or Y axis, right? I just traced the line of reflection and the image. Okay. Okay, so now what I'm going to do next is I'm going to take my actual trace paper and I'm going to turn it over. And I'm going to line the line of reflection back up, arrow on top of arrow. Okay, and now you guys can see where the reflected image should end up. So now what you can do is you can like hold it down, but then gently kind of lift up and put the points where they belong underneath. Does that make sense? So I'm just gently lifting up the trace paper and putting the points underneath the spot that they belong in. And I cover it back up and make sure that they ended up in the right spot. Now when you do this, you need to make sure you line up your line of reflection correctly, because if you have it off, then it's not going to be in the right spot, is it? No. Okay. So that's why I say trace the entire line, including the arrows. That way you make sure you really can line it up when you flip it back over. Okay? So now that I've got those points traced underneath, I put them underneath there. Now I can label them. This one is A prime, this one is B prime, and C prime. And now what I can do is I can go ahead and connect my dots, and I get my image of the figure. All right, on this next problem, we're going to go ahead and do the second method of reflection, okay, which is the counting method. In order to do the counting method, the first thing I need to do is I need to find the slope of the line of reflection, okay? So the slope of this line, I'm going to take a look at what is the rise and what is the run of the line of reflection. Remember, the line of reflection is line L. It's right here. Okay, so I'm going to pick two good points on line L, and I'm going to find the slope between those points. So what is my rise here? Am I actually rising or am I falling in this one? Yeah, I'm going down, right? If Slope Dude were skiing on this, what would he be saying? Nice, negative. Okay, so we're going -1 and then over 2, right? That's my slope. Okay? All right, after I find the slope of the line, I am going to use the opposite reciprocal slope. Okay, so what is the opposite sign of negative? Positive. What is the reciprocal of 1/2? Remember what reciprocal means? Turn it over, so it's what? 2/1. So here's my opposite reciprocal slope. Okay, now what I'm going to do is from each of these points on my triangle, I'm going to use this opposite reciprocal slope to count how many times it takes me using that slope to get to the line of reflection. And then I'm going to go that same amount of times across on the other side. So if I start at P, I'm going to go up 2 over 1. I get to the line of reflection. That took me 1 time. Does that make sense? So now I'm going to do it one more time across, up 2 over 1. This is where P prime belongs. Okay, now I'm going to go to R. I'm going to go up 2 over 1. Am I at the line yet? So I'm going to do it again, up 2 over 1. How many times did that take to get to the line? 2. So I'm going to do it 2 times across. Ready? Up 2 over 1, up 2 over 1. Put my point there. That is where R prime goes. Okay, next let's do Q. Up 2 over 1. Up 2 over 1. Up 2 over 1. How many times to get to the line? 3. So do it 3 more times. Up 2 over 1. Up 2 over 1. Up 2 over 1. 3 times. That's where Q prime belongs. Now, connect all of your points. Okay. So, if you use your trace paper, you're going to get the same result, right? If you were to trace the line and trace the image and then flip it over, this is where it would flip to, right over here, right? Does that make sense? This is just a different method, okay? Are there questions on this? And we're going to get plenty more times to practice this. Yes?
Do we have to use them, or can we just everyone use?
You can choose which one you like better. So if you like the tracing, use the trace paper. If you like the counting, use the counting.
But we don't have to use the counting.
Okay? Catherine? What's that? Because we're using the opposite reciprocal, and remember, opposite means that the sign changes. Okay? Now, why do we use the opposite reciprocal? okay? We use the opposite reciprocal because we know that lines that have opposite reciprocal slopes are perpendicular, right? And so really what I'm trying to do here is between these 2 points, I'm trying to create a perpendicular line that's perpendicular with the line of reflection, right? Does that make sense? I do the counting, same amount on both sides so that these parts of the line are the same size. Does that kind of make sense? Yeah? Okay. All right. Let's take a look at number 4. Okay? All right. So here's number 4. So on number 4, it says reflect the figure with the given vertices across the given line. What is the line they want you to reflect across here? Okay, everyone let's highlight that, and let's actually highlight your line of reflection, which is the x-axis. Here it is. This is the line we're reflecting over. Now, do you have the shape already graphed for you? No, so what should we do first? Graph it, okay? Everyone graph the shape. -4, 0, that's T. -5, 5, that's C. And -3, 2, that's W. Okay, so there's your shape. Now, if you like the trace method, you're just going to trace your line of reflection and the shape and then flip it over, right? Okay, so if you want to do tracing, you can do tracing now. If you want to do counting, this one's actually pretty easy to count. What kind of line is perpendicular to a horizontal line? If you have a horizontal line, what kind of line makes a right angle with it? Vertical line, right? So I don't even need to find the slope here because it's horizontal. I can just say that vertical is going to give me perpendicular, right? So I can just count vertically. 1, 2 to the line, and then 1, 2 below the line. That's where W prime goes. Okay, now for C, 1, 2, 3, 4, 5 to the line, 5 more below. 1, 2, 3, 4, 5. That's where C prime goes. Okay, what about T? What happens with T? Yeah, T is already on the line of reflection, right? So if I were to look at this shape and I did with my trace paper and I flipped it over, right? It's actually, T is actually not going anywhere, okay? It's staying the same. So T prime is actually in that same position, so I'm just going to go ahead and connect these. Okay, does that make sense what we did there? Okay. How many of you raise your hand if you were able to successfully flip that one, either method? Doesn't matter. Okay, good. Okay, let's take a look at the next one. Which axis are we going over on the next one? The y-axis. Where is the y-axis? Is it horizontal or is it vertical? Vertical. It's this one right here, right? Okay. Let's start out by graphing these points. Make sure you graph the points correctly, because if you don't graph them correctly, it's hard to get the right answer, right? Okay, so 1, -3. That's right here. That's point C. 1, -1. That's point S. 5, -5. That is Y. Okay. All right, so let's go ahead and flip this. We're going to flip it over the y-axis, so it's going to end up somewhere over here in this area, right? I'm going to count straight across, or I can use my trace paper. If I'm counting, it's 1 and then 1. And for point C, it's 1 and then 1. And for point Y, it's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Does that makes sense how we got the answer there? Yeah? Okay. Any questions on that so far?